Hi there, my name's Wajiuddin Bhatt, and this is gonna be my demo for the CM3020 AI Artificial Intelligence midterm. So, in this project, I've implemented a genetic algorithm from scratch to evolve virtual creatures that try to climb different types of terrain using Python and PyBullet. So, mo- Starting off, I'll just explain how I set up my experiment. So the creatures were evolved on three terrains: mountain.urdf, mountain with cubes.urdf, and Gaussian pyramid.urdf. And as well, their fitness of the characters was calculated based on their final z-axis height, which came about after the simulation. Each simulation was ran for 30 generations and a population size of 30. So how the evolution work? So basically, for evolution, I use fitness proportionate selection, also called the roulette wheel selection, to choose parents. The DNA was combined using the crossover G1 G2 function, and I applied three kinds of mutation points: point mutation, shrink mutation, and grow mutation, which is, by the way, also part of my extension, which I'll get into it. Showing the evolution on mountain.urdf, the mountain terrain had a slope that made it slightly difficult for creatures to climb, but regardless of that, we observed evolutionary progress and fitness values improved over time, and the creatures adapted their shape and movement patterns. As you can see, the character successfully climbed up at one point. So, for the second URDF, this train was a bit hectic, so the progress was erratic due to it having several obstacles in between. But it demonstrated how genetic diversity, one creature, managed a breakthrough in fitness, showing that evolution wasn't linear but regardless effective. So for the third URDF, this was probably the most stable terrain, with evolution being consistent and both max and mean fitness improved steadily. We saw creatures demonstrate more stable climbing behavior compared to the others. As for the exceptional criteria, to meet the exceptional criteria, I implemented three distinct mutation methods. This added complexity, diversity to the gene pool, which therefore led to better adaptation with a single generic mutation function, which helped the algorithm escape the local optima. So these are the three methods that I used. Why it is better than a tradition? Sorry, why so, why it was better than traditional mutation? So the reason is that this added deeper diversity to the gene pool, allowing the algorithm to escape local optima and discover more effective designs. Whereas, in comparison to a single mutation methods, this makes the evolutionary process more dynamic, structurally adaptive, and better suited to complex traits. So, as for challenges, which was one of my biggest limitations, is that my GPU is not at the not the best, which cause multiple limitations in terms of physical movement and being able to capture the fitness effectively. So yeah, in conclusion, these were my learning points. Thanks for watching.